Hi guys, Shavik here. Welcome back to our YouTube channel. So yeah, today with this video we are resuming our system design playlist on first we will mostly cover few of the important design patterns. So yeah, so today's agenda is we are going to cover one of the most common and important design patterns, that is of chain of responsibility design pattern. So before we start, give me a quick overview how actually the chain of responsibility design pattern is working, and on which cases you have to use it. So chain of responsibility design pattern is kind of a behavioral design pattern that actually lets you pass a request along a chain of handlers. So I will go with detailed UML diagrams, and along with the code also, Java code walkthrough also we will do. So no worry there. So just try to digest the theory part first. So it is kind of working when you have a request from a client, and on a single thread, or in a single thread sequential manner, you have to process the entire request. So now why we need the sequential processing? So that is depends on our business uses. So we all know that we can use completable futures or Spring Web Flux to do asynchronous processing, but on few of the cases it is we on few of microservices we have a this kind of strict uh, requirement where we have to do the processing of the incoming request in a sequence. So when you have that kind of requirements, so please be set your mind on that mindset that we definitely have to use chain of responsibility design pattern. So now, chain of responsibility design patterns where you can be already using. So on our day-to-day activity, like when you are vending amounts from an ATM machines, so there are few denominators of money ATM vending machine is providing, and when you ask for a certain amount, let's suppose X amount, your X amount is going to be divided. First, they are trying to basically vend your request of 1,000 amount with 1,000 denominator note. Indian rupees in any note, any currency, and then eventually, let's suppose they are remaining amount, they are trying to process with 500 rupees, then 200 rupees, like this. So there are few denominations of amount is already there in the vending machine, and your request is trying to get fulfilled by a chain. So let's suppose you have asked for 1,200. So your 1,000 rupees denominator is able to process only 1,000 rupees. Now for 200 rupees, 500 is not going to able to satisfy, and finally 200 rupees denominator note is basically able to serve your ask. So like this way, when we have this kind of things, that there are certain chain of processing we have to do with the client data, then make a very thoughtful thought on the chain of responsibility design pattern. And another use case that is very common, that is logger. So logger also internally using chain of responsibility design pattern, and this ATM one is one of the most common, and it has asked is one of my interview also. So basically they ask a kind of ATM vending machines, and on the low levels on the UML diagrams, I have to propose the design patterns is best suit for this particular use case. So yeah, so on this video we'll audit the exactly ATM withdrawal machines altogether. So let's get started on this. Okay, so on chain of responsibility design patterns, I will give you how actually the flow is actually working on chain of responsibility design pattern. So let's suppose we have a client, and this client is going to give us the request for a certain things. So this is our client. So now when a client request we have received to our server. Now let me just pull a server also. So this is our server, so when a client request come through your protocols that you are using, mostly HTTP or HTTPS as per your use case. So this request is come to your server, and let's suppose you have let's take the example of the ATM vending machines altogether that we have discussed. So this request first is going to come to a particular endpoint. So let's suppose client has asked us to withdraw some amount. Let's suppose we have exposed an endpoint named as withdraw. So now when a request is hit to our server to a particular endpoint, let's suppose this is our controller class that we have exposed, that is the withdraw controller, right? So now this withdraw controller's responsibility is to vend the request to multiple to some processing unit. So for the processing, let's suppose we have a what we can say, we have a denominators, because the denominators actually where the business processing is going to be happen, correct? So we have another class which is denominator. So here actually I have mentioned withdraw is a method, rest endpoints, and this is our controller class. This is our controller class. Now this controller is basically delegate the responsibility to processing this to some business unit, to some business unit. Now inside this business unit, the things that we have discussed, right? What we have discussed, that now our request should, what actually the greedy things that we can propose. Okay, so let's suppose I have asked for 1700. Let's suppose I have asked for an amount of 1700, correct? So 1700, this 1700 amount is, let me decrease the font of this. In the client request, let's suppose client has asked for 1700 withdraw. So now how many what is actually we have to thought here. So our thought process should be, we have to satisfy this 1700, and we have certain denominations of like notes in our ATM machine. So let's suppose we have one for 1000 denominations. So let's suppose we have 1000 denominations. Again we have, let's suppose we have 500 denominations, and let's suppose we have another one of 200 denominations, right? So this should be our 200 denominations. Now there should be someone who is basically taking the responsibility of first accept the request from the client. So client request came to our withdraw controller, we pass it to our business unit, and on the business unit we have three flavor of notes: 1000 notes, 500 notes, and 200 notes. Now the request should go in kind of a chain. The request should go in a kind of a chain. So first we will try to fulfill the client request with 1000 denomination note, with 1000 denomination note. Let me remove this, let me hold another. So first it will try to serve the request with 1000 denomination note. If some amount is remaining, let's suppose we have for 1700, 1000 is it's tried to fulfill, but 2000 is extra. 2000 is extra. So the next remaining 700 we have passed to the remaining. So here we have this text. Here we have 1700. It's processed. How much? It's processed. Let's suppose how much it is going to be processed. It is going to be processed 1000. 700 remaining. This 700 amount is going to, I think the font you guys able to see it, right? Or let me just bring it the font. So then the remaining 700 it passed to whom? The next 500 controller. Now this 500 out of 700, 500 is satisfied, but if it is trying to satisfy more 500, it is more. Then what it will do, it will basically vent the remaining amount, the remaining 200 amount, it is asked to satisfy the 200 controller. The 200 controller will satisfy those. So now on this you can see that the request from the client is processed in a sequential order. In a sequential way we have processed the client request. So now then what is the key points we have to take a note? Let me take a note. So the first point is client request we have to process in a sequential manner, right? Then you definitely have to think about this chain of responsibility design patterns, right? Then the second point is we have the same kind of we have the dependency of processing of the data from client. So we can't, for example, we can start processing with 200, then we can try to satisfy 500, then we can try to satisfy 1000. For this particular case it is fine, but let's consider if you have to do, if you have to get something from the DB, then you have to do some certain operation, and then you have to update the same things in the DB, some updated informations on the DB. Then you can't do, first you can't try to update on the DB, because the informations that you are going to get, right, the informations that you are going to get is you first have to fetch. So that's the reasons I am stating, when you have to process the things in a sequential way, then you definitely have to think about this particular chain of responsibility design patterns. So these 2 points is mostly the identifiers if on any interview, if it is asked for. Now, if we can quickly do the UML diagrams of this, if we can quickly do the UML diagrams of this, so how should we actually have to process it? So now I can draw. So I think we all agree here. So we definitely have a controller. Then from this controller, 1000, 500, 200, all are kind of a similar responsibility. Either they can process or they can bypass the request to its subsequent handler, correct? Either they can process or they can bypass the request to some subsequent handler. So now what we have to take a note here, when we have these things, so from the controller, we have to statically identify, we have to statically say, okay, let's start the processing with the 1000, whatever the maximum denomination I have. This is as per your problem statement. If you have some business logic that you have to execute on the chain, then we have the very static order here. But here, let's suppose we are going to greedily satisfy the client request, then we are starting with the 1000 denominations of nodes first, correct? So now I can create an interface. So let's create an interface. This interface, we can name this kind of a denominator, right? So we have a interface of denominator. Now client is, what client is actually looking for? Client is actually looking for the first chains. If from the controller, what actually our motto is, we have to trigger our first chain. Then eventually, if it is able to satisfy, then fine, the response is going to be returned from there itself, or else it should invoke to its subsequent handlers or the denominator here, correct? So now let's quickly create the concrete class from this. So we have two denominator. So these are the actual concrete classes. One is our 1000 denominator, which actually implements our denominator. Then we have, this is our another boy, and this is our another boy. So this is the 500 guy, this is the 500 guy, 500, and the next one is the 200 ones. The next one is the 200 guy. Fine. So we have three concrete classes created. This can expand. So now we first have to, from the controller, what is actually our trigger point? We first have to trigger this. We first have to trigger this particular handler, right? Now this handler either able to satisfy it, or if it is, so there can be cases, right? How the cases? Let me find any logical ones. If I can bring this here, and I need one more. This should be also here. So can satisfy. We will discuss how we will do the validations of is it doing the is it can satisfy or not. That things on low levels we will discuss. But try to understand on class diagram level, on flow levels, how actually it should work. Right? If you are able to understand that part, then next things is very easy for you. What is happening to this? This one I can get rid of. So we have these things. So first the request comes to this particular handler. If the request then go to this particular can satisfy. If the response is coming, let's suppose you have asked for the 1000 rupees, then it should be self capable enough to basically satisfy your request. Then you are going to vend out the response to the controller. Correct? Now if the case is, so if I can mark it, this is your point 1 of the invocations, this is your point 2, correct? This is your point 2. What is 2? Then your request come to this If it is stating that yes, then you are basically returning from 4.1, I can say, if you are able to satisfy, if it is an yes case, if it is an yes case. Or if it is not, then it is going to invoke its successive handler, its successive handlers, or here 500 denominator, right? If so, this should be my 4.2, and this is the bucket of no, this is the bucket of no. Let me just make it a little clear for you guys. Then same game, either request come to this, the request is 5, either it is able to satisfy, either it is able to satisfy, or it will vend the request to the next successive its denominator. So here also it is kind of a 6.2, I can write. If it is no, and it should be 6.1 if your request is going to be satisfied, correct? So this should be on the high levels your flow diagram. So this is our flow diagram. The request comes to our controller, their client is there on the top of that controller. From the controller we will choose which is the appropriate denominator to start our chain. We choose 1000, and from the 1000 we are trying to satisfy. Hey 1000, are you able to satisfy? No man. Then move the request, whatever you are able to satisfy, and the remaining things give it to the next denominator. Okay, I got it 500, got it 500. Are you able to satisfy it completely? No man, no. Provide it to 200, and from 200 from 200 we are going to return the response. And now consider the case, if let's suppose 200, that is for very specific of this ATM design purpose, but mostly you have a start of a chain, and you have an ending of your chain. But for this particular use case, let's consider we 200 also not able to satisfy, 200 also not able to satisfy, correct. So for that purpose we need a terminal handler. We need a terminal handler. So this is the happy case. We need this also. We need copy of this. This is coming to, sorry, not this. This one is not from this. So from the 200 we are going to go to can satisfy. If it is stating us yes, I can satisfy, move the request back to this controller. So this is our 6, not 6, it should be our 7 point, not 7 also, it should be our 8.1 if it is able to satisfy, and this should be our 7. And if it is not, if this particular handler also not able to satisfy, and this is our terminal, we don't have any further denominations, then we are giving this to the end handler, right? So we are giving it to our end handler. So I can say it's kind of a terminal handler. Terminal implementations also implements the denominator, right? And finally on terminal, when we are at terminal denominator, and let's suppose we have further amount, we have further amount pending, further amount to satisfy, then we can say from there we don't have any logic, we have to return the response for sure. So this is not, so from terminal handler we have to return the response to this controller with, based on the conditions. If amount greater than 0, then you can say remaining amount x not satisfiable, whatever as per your requirements. You can give it a message here. And if your amount is 0 on the terminal denominator, then you can give a successful denominations, and you can give whatever the, let's suppose you have used 500 of 500 denominations, note 1 note, 1000 2 notes, 200 1 notes, you can give that information also to the response. So as per that hardware, now your ATM had some hardware, so it will read that information. So okay, I have to basically emit 2000 rupees, 1500 to 200, and it will execute. So that is on the hardware part. But your software, your application, your controller should give that information. You have to, okay hardware, okay ATM hardware, you have to emit 2000 rupees, 1500 to 200, based on your calculation, based on the business logic we are going to write. So this is actually how the chain of responsibility design patterns, the flow diagram should looks like. Correct. Okay, so I hope it is clear, and if on any part you have any doubt on this particular flow diagrams on or the explanations that we did, then feel free to do a comments on our comment box. I will be happy to answer on that. Yeah, so with that we can start. We can quickly go to the code part, how actually we have done the coding of this particular ATM machines. So now, okay, so on the code part, I have created very simple like Spring Boot applications altogether. So let me just quickly check the recording is still happening. Okay, it's fine. This mic is also going to be fine. Okay, so yeah, so here you can see I have created a very simple Spring applications altogether. So if I can quickly show my POM to you. So on POM you can see that I have the dependency of Spring Boot starter wave of MVC, Spring Wave MVC dependency, and the test dependency, and along with the project Lombok dependency to basically use the annotation processing data builder, this whatever the Lombok giving me the power of annotation processing. So that's purpose I have used the Lombok dependency, and along with I have set up the plugins of Apache Maven plugins and the compilers, and corresponding the project Lombok I have added to the class path for annotation processing. Correct. Very simple, nothing fancy I have did, just a very straightforward Spring Wave with MVC sorry, and the project Lombok dependency. Now what we have, now quickly go to our controller class. The flow should start from the controller itself. So on the controller class you can see that I have the REST controller with a request mapping of withdraw amount, and along with the post mapping of this particular endpoint to basically withdraw the money. So on the request structure should be very simple Pojo, with amount as a long, with long as an amount from the client, the amount of money that the client want to basically vend out from the vending machine or the ATM machine. Right now, with this we are basically starting our chain. So here you can see we have the chain start denominator, and I am calling our chain start denominator ka dispense method. I am calling the chain start denominator ka dispense method. Now how I am basically defining who is my chain start denominator, that part I will come, because we have multiple denominator that we have discussed. We have 1000, 200, 500 terminal denominator, multiple. But before we start on the how we actually have built our chain and the chain start denominator, let me just quickly give the structure of the flow diagrams that we have discussed. The flow comes to this, and somehow it is able, currently let's consider it's a black box, the chain start denominator, and it is somehow able to invoke the first chain. We'll discuss for sure how actually we'll build the chain. Now as per the design that you can see, we have created a denominator class with dispense method and with setting our next denominator, which is also a kind of a, which is also taking a denominator, which is also taking the self. So it has a self reference also. So it is setting its next denominator. And the dispense method is giving the amount that is client has asked for, and the corresponding money denominations object. So this is the response that I am going to give. So that is the response that I am enriching. So to enrich it, I have basically pass it to all my denominators. So it is basically giving me, I need X amount of 1000 note, Y amount of 500 note, Z amount of 200 notes, and some message we will see, what it will be going to. So that is actually we are giving to the controller as a response. So that's the reasons you can see I am giving the response entity as a money denominations, and I am invoking our dispense method with an empty builder of it. So how we are enriching? We are going to enrich with the chains that we are going to create. So here you can see, first we have this 1000 denominator. Now how I am basically know that the 1000 is the first 1000 denominator? I will come. But as per our flow diagram, the 1000 should be our first chain. So chain start denominator that we have just saw in the controller, it should invoke this particular dispense method via the interface. It should invoke this particular dispense. So now just quickly understand what we have there in the business logic. The business logic is very simple. The amount that client has asked for, we are dividing it with 1000. So we basically got that many nodes we need to fulfill the client request, and we have the nodes. What is this nodes? So this nodes is basically stating how many nodes the ATM machine or the vending machine is currently have. The ATM machine or the vending machine is currently have. I might be using vending machine interchangeably with the ATM machines, but it is an ATM machine. So this is basically storing these nodes is how many nodes our ATM machine should have at the very start. So let's consider very simple example. In very early morning of the day, some of the like staff from the bank is basically putting X amount of 1,000, Y amount of 500, and Z amount of 200 rupees to our vending machine at the very start of the day to basically serve the client request throughout the day. So that's we are basically storing in our nodes. How we have basically stored? So you can see it is coming as a constructor. It is coming as a required tax constructor injection by Spring. But where we have actually defined it? We have actually defined it in our common config. So our common config, you can see we have defined we have initialized our vending machine to some available nodes. So our available nodes is a hash map with node count, which are the denominator we have 1,000, 500, 200, and we have initialized the bank employee has initialized the vending machine at the very start of the day with 10 count of 1,000 rupees note, 10 count of 500 rupees note, and 10 count of 200 rupees note. The vending machine has initialized the very start of the day, and I am providing it as an bean, so that whenever on which of the denominator, I know every denominator is needed except the terminal denominator, because it is not doing any operation to our ATM machine. Apart from that, every denominator is need the state of the ATM. So that's the reasons. The chain of responsibility, the ATM design pattern is also a state design pattern, also a state management design pattern. How the state of the ATM machine is going to be changed. But don't worry, we'll create a separate video of state management design pattern for sure. How actually the state is going to be changed, but it is going to be changed with the chains. So our chains are going to change the state of the vending machine. So here you can see we have initialized the state on the very start of the day with some XYZ amount of 1,500 and 200 amounts to our ATM machine, and we are providing it to a bean so that any denominator is needed to use, they can just do a required as constructor to a constructor injections to this particular bean, because it is available to the IOC container this type. So trust guys, no one is going to explain on that much low levels how actually the Spring is doing the internal work. So if you guys feel it helpful, so please consider to like it and subscribe it and share the videos to a friend circle who are also preparing for top product based company. I am repeatedly stating this. Now we can go to the 1,000 denominator class. We have our state of the vending machine, state of the ATM machines in the nodes, and I am getting how many 1,000 nodes we have. So it is coming to my available node count. So I need that many 1,000 node count, and I have that many available node count, and I am checking if I have any available node count. Okay, I have. Then I am checking if my available node count is more than my 1,000 node count, that is the required node count. If that is so, then I'm basically updating our vending machine state to be available node count to required node count. So from the available, I am minus some 1,000 node count. The 1,000 required node count I am going to negate from the available node count. I am storing to and remaining things I am storing to my vending machine. Here I am updating the state of the vending machine. Then I am from the amount, from the very initial amount, I am also subtracting the 1,000 node count into 1,000. So that many amount we have satisfied, and what is the remaining? I am storing it to my amount, and also I am enriching on this particular line, I am enriching my response object. On my response object money denomination, I am enriching with the 1,000 node count to be the 1,000 node count that we have used. And if my available node count is less, then we are going to use all of it. Then amount is going to be subtracted all the available node count, and money denomination also going to be updated with the available node count. Enriching of the response object done. State of the vending machine also, or the ATM machine also going to be changed. State of the ATM machine is also going to be changed. Very simple, very simple. Now the game, if I have certain amount to my hand, to fulfill, I need more amount which the current denominator is not able to fulfill, and it has some next denominator. Then what operations we have to do? We have to call the dispense method of its next denominator. So from 1,000, call comes to here and to the interface, and it is delegate the call to the 500 denominator. And here also you can see I have done the exact same business logic that we have discussed on the 1,000 with the 500, with the just change 1,000 to be 500. We can put in some helper method also to basically follow the non-duplicacy of the code that we definitely have to follow on the interview. But for the reference purpose, I just duplicate the same things, the same business logic we are basically executing. Correct? Now, I am just calling, if it is not able to satisfy, it is calling its next denominator. Now, I will come how actually 1000 know 500 it its next denominator. How 500 know 100 it its next denominator. How 200 know 200 terminal it its next denominator. How the things, how the chaining is actually built. I know you guys are waiting for that only, and also how actually we have defined the chain start, how call comes to the 1000 denominator first. That part I know you guys are eagerly waiting for that. I will definitely come on this. But before of that, I just quickly complete the terminal denominator, which is very simple. If this case, if it is a happy case, let's suppose 1000 is altogether able to satisfy, then call is not going to my terminal denominator. Let's suppose you have asked for 2000 rupees and I have 1000 denominator 2 note which can satisfy your request. Then the amount is going to be 0 and my terminal denominator is going to be invoked. And on terminal denominator we have very simple logic. If we have some amount, so that means that amount is not able to servable to the current denominations we have. So exactly same things we have written. Remaining amount, this amount cannot be dispensed due to the insufficient denominations. Perfect. And if we are able to satisfy, then just return dispensing completed successfully by enriching it to the response object, by enriching to its response object. Very simple, the terminal denominations, very simple. Now I will come to the chain, how actually we are building the chain, how actually we know this head of the chain is the first 1000 denominator is the head of the chain. So now I am just going to the business config where actually it is basically done the chaining things. So here you can see that we have created a business config with a required X constructor, and required X constructor, what actually the arguments we are looking for? We are looking for private final, this denominator. So this is a list of denominator. So now how Spring is basic. So this particular denomination list injection, Spring will do this particular list injection. How Spring will do? So that's the reasons you can see. If I go to my denominator, if I go to the overrided classes of it, the implementation classes of this, every class should have annotated with component. 500 denominator has, terminal denominator has, 1000 denominator has, everyone 200 is also has. So Spring is basically explicitly created the bean of 200, 500, 1000, terminal, everyone's beans. Spring has already created when the server is going to be server started phase. Spring has already created. And what is the everyone relying to whom? The denominator. Everyone is the implementation of the denominator. So when I am asking Spring, hey Spring, give me all the beans that you have is type of denominator and inject to the list. Spring is able to do so because every child IMPL class of the denominator has a component annotation. So see guys, so this is the clarity actually you have to understand on. I have explained the things on very details on the DSA part, and I am trying to explain the things as much as I can on very details with the very clarity. So that's the reasons we have annotated with that component. Every annotations, everything has a logic behind that. So Spring is able to inject all the kind of denominators to my denominators list. If that is so what we actually have in my denominators, the actual objects of 500, terminal, 1000, 200. We have the actual object stored. Now when we have all the objects stored, is our job is done? I think almost. Now we have to create the chain with the objects. Now you can see provide denominator chain. This method, we have created a new hash map. On hash map, what we are storing, we have created the denominators with the things of with map key as string and the value as the object. And the map key string is coming from the denominator. Whatever the denominator object we have, we are iterating over the denominators list that Spring just give me. And with that, I am calling the denominator.get denominator identity. So that's the reason I have given an identity for every class. So here you can see that 500 has its own identity. So this is just returning a simple string. From this enum.name, it is just giving me a simple string as a key, but the value is the object, the 500 denominator object it is holding on the hash map that we are discussing here. So the denominator's key is the simple string, the identity of every denominator, and the value is the actual object.
Correct. Agree, totally agree. Now we have to know the ordering. Now we have to know the ordering in which we have to iterate, we have to create the chain. Now the chain creation things is pending. Now we have just saw this denominator identity and it's an enum. If I do the values, then it is giving the values of the denominator in the order I have written. So first I have written 1000, then 500, then 200, then terminal. So on the same orders. So here basically I have implicitly defined the ordering. I have implicitly defined the ordering in the enum itself, and when I'm doing the dot values, it is giving me the ordering. It is giving me the denominator ordering. So I got the ordering. Now I have to create the chain. I have the object. I have the ordering. What I need actually to rest to create the chain. I definitely need these two things. I need the object and I need the ordering. So two things I have. Now let's create the chain. So I'm iterating to my denominator identity list of size. I'm iterating to it and I am getting the first current denominator. Who is the current denominator? Denominator ka map. On that we have to get the denominator identity of get. Denominator identity list is the denominator identity that we have just built from the denominator identity of values. From that we are getting the current denominator and we are calling it our denominator map with the enum name, so which is actually the key we are also using on the identity of every class. So we got our current denominator object. Similarly we can fetch our next denominator object just to change to I plus 1. We got our both current and next denominator and we are setting our current denominator next denominator to be our next denominator. That's it. So our chain creation is also done. So do you guys feel we have to change anything? Let's suppose on future if there is an ask for 50 rupees denominator, do you feel guys we have to do any changes on this? Or any of them is like denominator name specific? None of them. The chain creation logic should work as it is. You just have to create a denominator and you have to just create a enum of it. And you can create this particular 50 rupees how many note count you want to put on the ATM machine for that purpose, and you just have to create the identity enum of it. You can just replicate the same identity of from denominator. You can just inherit it and you should be good. You don't need any changes in our chain creation. So chain creation logic is very generic. It should work on, currently it is working for 4 denominator. It should work as it is with n number of denominator without any single change in this particular chain creation logic. Now actually finally what we have to basically looking for our controller, what is actually the controller is waiting for? The head of the chain. Give it. We should have denominator map dot get. Same things, denominator map dot get, denominator identity list of get of 0, the head of the chain dot name. I am fetching it, that particular denominator from my particular denominator map, and I am vending this object, the chain start object. So 1000 denominator class is vending out as an object from this particular provides denominator object. And here you can see I have annotated with bin. So whatever the emission this particular method will do, Spring IOC is listening on this. Spring IOC is listening to it. Spring basically listen. Okay, it has emitted me a denominator class, and inside that it has a 1000 denominator. I have to store it. Now why I have basically explicitly named it as a chain start denominator? Because tell me guys, you should be able to tell. Because I have defined type of denominator also. 500 also, terminal also. These all are type of a denominator altogether, right? These all are kind of a denominator altogether. So Spring is also stored them also a denominator. Then how, whatever the emission I am doing from this business config as a bean, how Spring is basically stored it explicitly from the other denominator. So that's the reason I have explicitly tell to Spring that, hey Spring, this denominator is a special one and you should have take some reference of it with some chain start denominator. So that's the reason I am naming it to a chain start denominator. And when on our controller we have to refer our chain start, we want to get our chain start, we are going to fetch from the Spring. If we are not writing this particular line number 21, if we don't write it, then Spring is not aware of which particular denominator object you are looking for. Is it 500? Is it 200? Is it 1000? Which one? Terminal? Which one? So that's the reason I am also wiring it with the qualifiers. So that is the use case of the qualifier, and I am asking Spring explicitly give me the chain start denominator, that is the 1000 denominator, and Spring is able to inject it and the program should call it as it is. So from 1000 we are calling the dispense method, and from this particular dispense method we are eventually calling the chain. Clear? Clear, guys? So now I think it should be going to be more clear when I am going to basically show you the uh, running of this particular application. Let me just start the application in the debugging mode. I have added the required debugging points. You can see on the very starting, like Spring starting, or the bean creation part, you can see how actually the beans are going to be created. That part also you are going to get the gist. So please be stay with me. So I am starting the applications with the debugging. Sorry, my breakpoints are muted. Let me just restart. So here you can see first calls comes to the this ATM machine initializations, where the call we have call in our common config, where we are basically starting the very start of the day, the employee is enriching the ATM machine. So on that part, our very start, the call has land on. The call has land on. If I go to my next debugger point, then it is go to the terminal denominator to basically initialize terminal denominator object. Then it is initializing 500 denominator, 1000, 200, any random order. It is basically initializing. And then when we have all the denominator initialized, then we are basically expecting our call should go to the chain building logic. Our call should go to the chain building logic. Let's see. So you can see our call is land on the chain building logic, that is the provides denomination chain. And if I can show you here, you can see that, or maybe here, you can see that all our denominators list is basically enriched by Spring. I didn't do. I have just used required X constructor with list of denominator I am looking for, and Spring internally did enriching of 500 denominations. It's injected terminal 1000, 200. It's basically injected all the object. It's actually the whole together object of 500 terminal 1000, 200. It's basically give me the all the denominator object to this particular list, right? Now if I can go to the step over to it, so you can get it how actually on line by line how the things are working. So my map has initialized. Now my map has enriched. If I can show my map, I have the key as the identity and the value as the whole together object. The value as the whole together object. 1000 object. Terminal object, like this. Now if I go further, it's come to the for loop. It's picked the first one, denominator list of I0. Who is the current denominator? If I can go next, my current denominator is choose to be the 1000 denominator, who is basically or taking the ordering. Here we have the ordering. So if I can show you the denominator list, on denominator list you can see the ordering. We have 1000, 500, 200, terminal. We have the ordering here, and we have the object here. Now we just have to play the plug-in play. We just have to do that exactly we are doing here. So we have current denominator as 1000. If I can go next, my next denominator is going to choose to be the 500 denominator, exactly that I am looking for. And now I am calling my current denominator, my 1000 denominator ka set next denominator. I am setting it to the, if I can go here, it is going to enrich my 1000 ka denominator ka set next pay. It is storing the 500. Like this way it is building the chain. So again it is going to the next I to be 1. It's choose current denominator 500, next denominator 200. See, look at here, guys, then done for I equals to 1, go for I equals to 2, current denominator should be 200, next denominator is choose as the terminal denominator. Exactly. Now it has done for the for loop. It is out of the for loop, and it is giving me the chain start to be as a bin, right? So now if I can click on the run, the application is running. Now if we are go to our postman I have set up at localhost 8080 with withdraw money. If I can ask for 1700, then if I want to see it, you can see the call comes to the dispense method of 1000, because chain initialization and chain creation we have already done at the server start. And you can see on the very first of the go, if I am the very first client, then I have all 10 count of all the denominators node, and I am the first client. Now from the 1000 denominator, if I can click on the next debugging point, call goes to 500, and if I can try to see the nodes going to be 9000 to 1 satisfied, one of 1700 is satisfied by 1000. So the remaining amount in the vending machine, the node count is 9, and the remaining amount also becomes 700 when I am at 500 denominations. And my money denominations also, you can see that 1000 has enriched with 1 count. That is the response object I am looking for, correct? If I can go further, money deducted to 200, notes count should be 99, 1 denominations I have used from my vending machine, and also my response should have also the 1 count. Exactly it is, exactly it is. Go further. It is in the terminal denomination with the amount to be 0. And if the amount is 0, it should go to the dispense completed successfully. And what is the money denomination object we have? We have 1 on of each. And if I can go to line by line execution, you can see that our message also have enriched with dispensing completed successfully. Dispensing completed successfully. Right? Exactly. Now if I can resume the program is resumed. Go to the postman. We should have a 200 OK. And yes, we have 200 OK with 500 of 1 count. Message is dispense completed successfully. 1000 count of 1, 200 count of 1. Correct. Let me try with something like 800. So let's suppose my next customer is the 800, right? So hit it. So what is the expectation? Like before running it, set our expectation. 1000 rupees is going to be satisfied by 1000 controller, 1000 denominator. 500 is going to be satisfied by 500, 200 is going to be satisfied by 200, 100 rupees I remaining that I am not able to satisfy, and I am giving that 100 rupees remaining 100 rupees I am not able to satisfy. That exactly we are looking for. Now start the run. Control come to 1000. Now on the notes you can see it's still not basically start the processing, but here you can see our vending machine, our ATM machine state is so that's the reason I am stating it's a state management design pattern also. So here you can see for the next client, if I am the very first client on a particular ATM machine, if you are going to the next client, for you the note count should be decreased, not the very start of the day whatever the note count on the ATM machine. For your case it should not be that, the count should get reduced because I done some withdrawal. So due to the first customer withdrawal, our ATM machine current status I have 1009 note, 509 note, 209 note, and with this I have to satisfy 800 amount. See now we can see the execution. On 1000 we have the call. From 1000 call goes to 500 with the amount decreased of the remaining amount is 800. 1000 has done. And on notes also, is it updated? Yes, note count of 1000 becomes 8. Money denominations, yes, updated. Go to next. Go, amount becomes 300. We are at 200 denominator. Notes count is 88 on our ATM machine. 1000 to 1 done, 500 to 1 done. Money denominations 1 denominations I need to withdraw. The hardware need to vend out. The hardware need to emit. Go to the next denominator, terminal denominator. I have remaining 100 rupees. Now the amount is greater than 0. You can see now the amount is greater than 0. And on money denominator, you can see we have 1 of each note we are emitting, and still we have some amount is in our hand. So amount is not 0. Correct? Now if I can go next, so you can see our message is enriched with remaining amount 100 cannot be dispensed due to insufficient amount. And if I resume the program, go to the postman. On postman also you can see the remaining amount 100 cannot be dispensed due to insufficient denomination. I hope guys it is clear to you. I have showed you how actually from configuration initializations, the entire execution on runtime execution when a particular thread is trying to do the operations to our ATM machines, how actually the flow is working, to the very start of creation of chain config component, how the things are basically spraying is initially. If this is helpful guys, please feel to share the videos to your friend circle, and please provide a like, and please provide a valuable comments, valuable feedback to your to our comment box, so that we can improve. And please share the videos to your friends circle who are also preparing, and please do consider to subscribe the videos. Please do, because to make such quality of videos, we need a very good brainstorming and along with the researching. So if you feel this video is helpful, so please consider to like the video and share the videos to your friends circle, and please consider to subscribe to our channel. So this is actually how on high levels the chain of responsibility design pattern is working. So I will give you the source code. Let me just stop the server. So I will provide the source code to you guys so that you can play some tweak with the source code. You can add some debugger point. You can run the things to your own system so that you can have the understanding of how the things are working, to basically do some plug-in play you guys can do, right? Okay, so with this note, I think we are very good to close this video. So let's meet with some next video with some defined design patterns. Okay, so thank you guys. Bye.